the AMC 8 competition from 2015. I'm just going to go in order, and if you have any questions, type in the chat, I'll answer them. And I'll stop periodically to ask anyway. So we'll start with the first problem. Alright, we have how many square yards of carpet are required to cover a rectangular floor that is 12 feet long and 9 feet wide? And it tells you that there are 3 feet in a yard. So if we consider a carpet, if it's 12 feet long, then we can convert this to feet, convert to yards, because we need square yards. So 12 feet is 4 yards because we're told there are 3 feet in a yard. So one dimension would be 4 yards, and the other dimension, 9 feet, would be equivalent to 3 yards. So to find the area of the carpet, we just do 3 yards times 4 yards, and that's 12 square yards. So our answer is 12. Alright, on to question 2. We're given point O is the center of octagon ABCDEFGH, and X is the midpoint of side AB. And we want to know what fraction of the octagon is shaded. So if we connect the center to every point, we will make a bunch of triangles that all have the same area. Every one of these triangles should be 1/8 the area of the octagon. So we can basically just count how many triangles are and how many of them are shaded. So because it's an octagon, there will be 8 triangles. And we can see that 1, 2, 3, and a half of them are shaded. We're told that X is the midpoint, so we know this is 1/2 of this larger triangle ABO. So we basically just have 3.5 divided by 8. And if we simplify that, it's 7/16, just multiplying the numerator and denominator by 2. So our answer is 7/16. Okay, so those are the first 2 problems. Keep going. So Jack and Jill are going swimming at a pool that's 1 mile from their house, and they leave simultaneously. Jill rides her bicycle at 10 miles per hour, and Jack walks at 4 miles per hour. We want to know how many minutes before Jill arrives. So if we know that Jill rides at 10 miles per hour, then she'll go 1 mile in 1/10 of an hour. So 1/10 of an hour is 6 minutes. And for Jack, since he goes at 4 miles per hour, he will travel 1 mile in 1/4 of an hour, which would be 15 minutes. And to find their difference, we just do 15 minus 6, and we get 9. Pretty straightforward. Alright, on to problem 4. The Centerville Math School chess team has 2 boys and 3 girls. And the photographer wants to take a picture of the team, and they want them to sit in a row with the 1 boy at each end and the 3 girls in the middle. And we want to know how many arrangements there are. So we have 2 girls, and they have to go on the, we have 2 boys that need to go on the ends. So we have 2 possibilities for how to arrange them. Right? We could either have, the first boy, we'll call him A, on the left side, or we could have B on the left side. So that's 2 possibilities. And now for the middle 3 spots, we have to put the 3 girls, which will say are C, D, and E. Not very good, D. Alright. So we have 3 possibilities for which girl can go in this second slot. It could be C, D, or E. So there are basically 3 choices. And then for this middle slot, we only have 2 choices because one of the girls is already in the first spot, so there's only 2 left. And then for the 4th slot, there's only 1 girl left. The other 2 have already taken their spots, so there's only 1 choice left. And this is a total of 6 possibilities. Do 3 times 2 times 1 is 6. So you do 2 times 6 is 12. And I'll just elaborate that for the boys. Whoever sits on the left, there are 2 choices, and obviously there's only 1 choice left for the person on the right. Alright, so far so good. So for the 5th problem, I'll scroll to the top. Alright, so we're given a bunch of scores for Billy's basketball team, and we want to know which one of the statistics will increase if their team scores 40 in the 12th game. So the first thing to notice is that 40 would be the lowest score that they gotten all season. So that means that no, the average cannot increase because this is a new lowest score. And the median also won't increase for the same reason. And actually right now, since 40, this is the first time they've scored 40 points, the mode actually won't change. You can see they've actually scored 58 points 3 times, so it definitely won't change. So it won't increase either. Now we're just looking at mid-range or range. And since 40 is the lowest score, that would increase the range. Their highest score so far is 73. Lowest score before 40 was 42. So the range would be the difference between these two, which would be 31. But when they score 40 points, that increases the range by 2. So the answer is A. Okay, question 6. I'll draw it over here. So we have an isosceles triangle, and we're given the side lengths, 29, 29, and 42. And we want to find the area of this triangle, mid-range. So mid-range is pretty much the mid-range is pretty much if we take the highest number and the lowest number, and then we take the average, that would be the mid-range. So the middle of the range, right? And when we added the 40, that actually lowers the mid-range because the range is now the same highest number, but a lowest number. And that's going to bring the middle downwards. So I hope that answers your question. Okay, back to question 6. Okay, so we had this isosceles triangle and we knew the side lengths. So to find the area of a triangle, we like to use the formula base times height divided by 2. So we want to draw a height, and this height will be perpendicular. And one property of isosceles triangles is that when you draw an altitude, it also bisects the base. So this 42 is pretty much cut in half, basically, 21 on each side. And we'll call this perpendicular point D. So now we need to find this height H, and then we'll be able to finish. So what we have to do now is use the Pythagorean theorem on either triangle ADB or CDB. It doesn't really matter since these two triangles are the same. So we know that 29 is the hypotenuse because it's across from the right angle. So we do 21 squared plus h squared equals 29 squared. Now we can expand 441 plus the height squared is equal to 841. So now we have the height squared equals 400. And that obviously means that the height is 20. And the height cannot be negative 20, obviously, because distances have to be positive here. So now we know the height, which is 20, and we can finish by using the base times the height divided by 2. So that would be 42, the base, times 20 divided by 2, which is 420. Any questions about that problem? All right, cool. Let's move on. All right, we have 2 boxes, and each of the 2 boxes contains 3 chips, numbered 1, 2, and 3. And 1 chip is drawn randomly from each box, and then we multiply our 2 numbers. And it's asking us for the probability that the product is even. So we know that multiplying 2 numbers can only be odd if both of the numbers are odd. Right? If even one of the numbers is even, then the entire product is even. So we can first calculate the probability that the product will be odd, and then use 1 to subtract that. So 1 minus the probability of an odd product will be equal to the probability of an even product. And the reason for this is that basically the product has to be odd or even. So the probability of an odd plus the probability of an even has to add up to 1. So taking 1 and subtracting one of those two will give us the other. And the reason this is good is because it's a lot easier to calculate the probability of an odd product. Right? For the first number to be odd, that's a 2/3 chance. And for the second number, it's also a 2/3 chance. Right? 1 in 3 out of 3 numbers. So that's 4/9. So now to find the probability of an even product, we just do 1 minus 4/9, and we get 5/9. Any questions about that? All right, cool. So we want the smallest whole number larger than the perimeter of any triangle with a side of length 5 and a side of length 19. So the key here is that it's any triangle. And since we want the smallest whole number larger than any perimeter, we want to look at the extreme case where the triangle has the biggest possible perimeter. Right? When we check the biggest possible perimeter, we just have to add 1, smallest whole number larger. Yeah, I can't really get rid of the background noise. Sorry about that. No, I don't think I can do anything about that. Well, I'll see if I can fix that next week. Okay, so our triangle has one side of length 5 and one of length 19. So when we have a triangle, adding up any two sides, A and B, has to be greater than C. A plus B greater than C. And this is known as the triangle inequality. And the reason for this is if you imagine a triangle where this is C, and then A and B are both flat, right, but they still add up to C, then instead of a triangle, we basically have a line. And in this case, A plus B would be equal to C. And then if A plus B is less than C, then it just won't reach, right? No matter how flat A and B are, so even if they're on C, they still won't connect. So A and B have to add up to something greater than C in order to form a triangle. So with that in mind, we want to find the largest possible perimeter. And we'll use 5, 19, and then we'll say that these are the shorter sides. Since if the unknown side is the longest, that'll produce the largest perimeter. So 5 plus 19 is 24. So the longest the last side could be is like 23.99999, right? Repeating, or forever. Basically just under 24. So if we add up all of these, we would get 47.99, and so on. So the largest, or the smallest whole number larger than that would be 48. Okay. That makes sense for everyone? Alright, let's move on. So on her first day of work, Janabelle sold 1 widget. On the second day, she sold 3. On day 3, she sold 5. And on each succeeding day, she sells 2 more than the previous day. And we want to know how many widgets she sells after 20 days. So we could start by making a table to look for a pattern. If it's not immediately obvious what to do, pattern is where you want to look. So we'll put the number of days on the left, and since we want to know how many total widgets she sells, that's probably a good thing to list. So after 1 day she sells 1, and after 2 days she sells 1 plus 3, which is 4, and on day 3 she sells 5 more, so for a total of 9, and then adding 7 we get 16. And you can see a pattern here, right? All of these are square numbers. And if you continue this, you'll see that it does work. And you can see that on day X, she's basically sold a total of X squared widgets. So after 20 days, she will have sold 20 squared, which is 400 widgets. And I'll draw cool diagram to try to show you how this works. So if you imagine this blue square as the first day, and then these red dots as the second day, you can basically just keep going and adding rings like this every day. So you can see the first day is 1, and then 3, and then 5, and then 7. You can see each sort of layer has 2 more widgets, right, than the previous layer, but in the end it still forms a square. So that's how we solve problem 9. So on the first day, she sold 1 widget, right? On day 2, she sold 3. Yeah, that's correct. So on day 3, she sold 5 widgets, but that would be a total of 9. So we need to make sure we, differentiate between widgets per day and total widgets. So the number of widgets is going up by 2 each day for the number she sells that day, but the total is going to the next square number. Does that answer your question? If anyone else is confused, let me know. Okay, yeah, so 9 widgets total and 5 widgets on that day. Hope that makes sense. All right, let's go on to the next question. Just pull this up. All right, we want to know how many integers between 1,000 and 9,999 have 4 distinct digits. Distinct is the same as different. And we can see pretty easily that this is basically just all of the 4-digit numbers. Right, 1,000 is the smallest and 9,999 is the largest. So we can consider the 4 digits as like individual spots, and we can just ask ourselves how many different digits can go in each of those slots. So for this first slot, we can pick any number 1 through 9. Obviously, we can't start with a 0, because then it would be a 3-digit number, right? So we have 9 choices for the first number. And then for the second number, we can't pick the same one as the first digit. So that would put us down to 8 choices. But now we can actually use 0 because that doesn't create any problems. So that adds another choice. So now we have 9 choices again. And for the third digit, we don't get an extra digit to use. So we're just down to 8 because we just used 1. And then the same for the last, we'd only have 7 choices. So all we have to do now is multiply 9 times 9 times 8 times 7. And that gets 4,536. I'll let you do the multiplication. Any questions? Pretty straightforward problem, I think. All right. Next question is actually pretty similar. In the small country of Mathland, all automobile license plates have 4 symbols. And we're told the first must be a vowel, and the second and third must be different letters among the 21 non-vowels, and the fourth must be a digit. And we want to know what's the probability that the plate reads AMC 8, assuming it's all random. So once again, we have 4 slots. This is a little different since it's probability, right? And in probability, we want to find the number of successful outcomes divided by the number of total outcomes. Only if they're all equally likely, of course. And we obviously only have 1 successful outcome. It's AMC 8. And now we just need to find the number of total outcomes. So, how many different choices do we have for a vowel? We have 5. That's what they tell us. And then we're told the second and third must be different letters. So, and there are 21 choices. So the first consonant, we have 21 choices. And then for the second consonant, it can't be the same one as the one we just picked. So we have 1 fewer choice, only 20. And then for the last slot, we have to pick a digit 0 through 9, so we have 10 choices. And if we multiply this all together, we can pair the 5 and the 20 for 100, and then add in the 10 for 1,000. And so we can see it all multiplies to 21,000. So our answer is 1 out of 21,000. So that's B. That's a probability we get AMC 8 given these conditions and if it's all random. Okay. Alright, we want to know how many pairs of parallel edges a cube has. So we'll first look for which edges are parallel. You can see this one is obviously parallel to this one, and these two as well. And then we have more parallel edges here. And then we also have one more set going up and down. So pretty much just one set of parallel lines for every dimension. So to calculate the total number of parallel edges, we can just look at one color at a time. So how many pairs of red edges, for example, could we pick? Well, we could pick AB with any of these three, right? So we can put down 3 for AB, and then another 3 for EF, since that can also go with any of the other 3. So we can see that we basically can choose any of the 4 vertices for the first in the pair, and we have any of the other 3 for the other one in the pair. The only problem with this is that if we picked EAB and then EF, well, this actually goes both ways. We also could have picked EF first and then AB second. So we have to divide by 2 to find the number of pairs of red edges. So we have 6 pairs. And then since there are 3 colors, and every color is pretty much the same, right? They all have 4 edges. So we just have to multiply by 3 to get our answer of 18. And let's see. Any questions here? All right. Moving on. We want to know how many subsets of the set 1 through 11 can be removed such that the average is still 6. So just looking at the set right now, we can pair them up like this: 1 and 11, 10 and 2, 3 and 8, and then 7 and 5, and then just 6 by itself. But we can see that each pair adds up to 12, but that also means it has an average of 6. So we can see that the average of the set right now is already 6. So if we remove 2 numbers and keep the same average, then the average of the numbers that we remove also has to be 6. So actually the number of subsets of 2 elements that we can remove is exactly the pairs that we already connected here. Removing 1 and 11 will keep the average at 6, and so will any of the other 3. Oh, sorry, I missed one pair, 4 and 8, right? So there are actually 5 pairs that we can remove. Okay, so that's question 13. Any questions about that? Alright, let's move on. Question 14. We want to know which of the following integers can't be written as the sum of 4 consecutive odd integers. So 4 consecutive odd integers. We can imagine that they're all surrounding one even integer. We'll call it 2k. 2k is an even number because of the 2, and k can be any integer. K doesn't have to be even, but 2k will be even. So the surrounding odd integers will be 2k plus 1, 2k plus 3, and then on the other side 2k minus 1, and then 2k minus 3. And if we add these all up, we would get 8k. And then this minus 1 will cancel with the plus 1, and the minus 3 will cancel with the plus 3. So we actually just get 8k. And now the question is just which one of these is not a multiple of 8? And the only one that's not a multiple of 8 is 100. There's our answer for problem 14. Alright, problem 15. At Euler Middle School, 198 students voted on 2 issues in a school referendum with the following results. 149 voted in favor of the first, and 119 voted in favor of the second. We know 29 students voted against both issues, so we want to know how many voted in favor of both. So I'll start by drawing a box to represent the entire student population, which we know is 198, or rather the number of students that voted. And I'll draw 2 circles, one for each issue, and then I'll put 29 right here outside of both circles because they voted against both issues. So if we do 198 minus 29, that's 169 students that actually voted in favor of at least one issue. So we know that there are basically 169 students within these 2 circles. Now if we add up the 2 numbers for the number of students that voted in favor of each issue, we would get 268. But that's obviously a lot more than the 169 students that there actually are. And that means that some students had to have voted in favor of both issues. So the students that voted in both issues would be counted twice in this 268. So all we have to do is find the difference between these two. It's the difference between the middle students getting counted once here and getting counted twice in the 268. So the difference is 99, and that's the number of students that voted in favor of both issues. I'll give people a second to digest that and ask any questions. Okay. So, in a middle school mentoring program, 6th graders are paired with 9th graders as buddies. And no 9th graders send more than one 6th grade buddy. We know that 1/3 of the 9th graders are paired with 2/5 of the 6th graders. We want to know what fraction of the total number of 6th and 9th graders have a buddy. So let's consider the minimum number of 6th graders and 9th graders. So we could have 5 6th graders where two of them have buddies. So let's do that. Right, this is the smallest possible case. And we know two of these will have buddies. And then 1/3 of all the ninth graders have buddies. So we need two ninth graders that have buddies, which means that we would have 6 ninth graders. And then 2 pairs would have buddies. So in total we would have 11 students, and 4 of them would have buddies. So our answer is 4 11ths. And the reason this works is because we could scale this up no matter how many students there are. We could just consider this entire thing as one group and just multiply this however many times we need to. Okay. Question 17. Jeremy's father drives him to school in rush hour traffic in 20 minutes. And one day there's no traffic, so his father goes 18 miles per hour faster and gets him to school in just 12 minutes. We want to know how many miles it is to school. So first we know that distance is equal to the speed times the time. So we'll consider a normal day. It takes 1/3 of an hour, 20 minutes to get there. And this would be going at an unknown number of miles per hour. And then when there's no traffic, it only takes 1/5 of an hour. And we would be going at x plus 18 miles per hour. And these are both equal to the distance from their home to school. So these two would be equal. So now we just have to solve for x. X over 3 equals x over 5 plus 18 over 5. Now if we convert to a common denominator, we'd have 5x over 15 equals 3x over 15 plus, we can keep the 18 over 5 here. And then that would mean that 2x over 15 equals 18 over 5. Now we'll multiply by 15 on both sides. Get 2x on the left and 54 on the right. And all of this means that on a normal day they go at 27 miles per hour. So we can use either equation to find the distance, but the first one's easier, so we'll use that. So 1/3 of an hour, 27 miles per hour, that means that the answer is 9 miles. Alright, any questions about that one? Okay. Clear? Then we'll move on. Okay. We have this magic square, so to speak, and we're told what an arithmetic sequence is. It's where every term after the first is obtained by adding a constant to the previous term. So they give us an example here. They start with 2 and then add 3 for every term after. And we were told that every row and column in this 5x5 array is an arithmetic sequence with 5 terms. So we want to find the value of x. So we'll try to find ideally one of these sort of middle of an edge boxes, because those are going to be most useful. So we'll start with 1 through 25, and that's a total jump of 24, which is split among 4 jumps. So 24 divided by 4 is 6, so we know every jump is 6. It's a bad 9. Okay, now let's try to find the box across from it so that we can just look at this column. So we'll look at the difference between 81 and 17. So if you do the subtraction, you get 64. And once again, this is divided among 4 jumps, so every jump will be 16. So this will be 33, 49, 65. So now we have the 2 endpoints of this column, so we can find x. So the difference between 49 and 13 is 36. So if we divide that among 4 jumps again, that's 9 per jump. So this would be 22, and then x would be 31. That's our answer. And just a note, we could have done this by finding the boxes on the sides as well. Just doing the same thing, finding the difference, dividing it by 4, and then finding 2 jumps. We can use either. All right. Question 19. We're given a triangle and the vertices, and we want to know what fraction of the grid is covered by the triangle. So it's not really clear where we're going to find a base and a height for this triangle. So it's probably best to just use some subtraction. Let's see how we do that. Well, there are 30 squares on this grid, so we know that the denominator of our fraction will be 30. And now we'll look at this smaller rectangle, which contains the entire triangle inside. So the area of this rectangle itself is 12, 3 times 4, and we want to subtract the rectangles along the outside. So this first triangle at the top, use base times height divided by 2. So 1 times 3 divided by 2, this is 1.5. And it's the same story for this triangle, also 1 times 3 divided by 2. For this triangle along the bottom, it's 2 times 4 divided by 2, so that's an area of 4. And now adding up all of the triangles along the outside, they add up to 7. So we'll subtract that from the original rectangle, and that means that our triangle on the inside had an area of 5. So we'll divide that by the entire grid now, because we want the fraction of the entire grid. We get 5 divided by 30, which is 1/6. Okay, any questions about this question? I'll leave this up while I do the next one. So we're told that Ralph goes to the store and buys 12 pairs of socks for $24. And some of them cost $1 a pair, some cost $3, and some cost $4. We know he bought at least 1 pair of each type, so we want to know how many $1 pairs he bought. So the easiest way to deal with this restriction is to just get it out of the way. We'll first write down 1 of each pair, which would be 3 pairs, and it would cost him a total of $8, 1 plus 3 plus 4. And so that leaves us with $16 for 9 pairs. So from here, it's probably easiest to just work from having all 9 pairs be $1. And pretty much what we need to do is swap them out for more expensive pairs until we get to 16. So we can swap for a $3 pair, which would add $2, or we could swap for a $4 pair, which would add $3. And we need to add $7. And the only way we can add $7 is to add $3 once and $2 twice. So that leaves us with $6 $1, $2 $3, and $1 $4. That's 9 pairs, and that costs $16. So if we add that back to our 3 pairs from before, we had 6 here, and add 1 back, 7 $1 pairs. Any questions about that problem? Okay, take these down. We're given a figure and we're told that ABCDEF is equiangular. So all the angles are equal, but not necessarily the sides. Also given 2 squares with these areas, 18 and 32. We're told that JBK is equilateral. We're also told that FE equals BC. So we want the area of KBC, the triangle. Alright, so that's a lot of information. We'll start by trying to figure out what we need. So first, we'll try to find this angle. So we know this is 90. And in a hexagon with all the angles equal, we know every angle is 120. We know that an equilateral triangle has angles of 60. So if we add these 3 up, we'll get 270, which leaves 90 degrees for KBC. Because we know there has to be 360 degrees when you go all around the point. Okay, so now we have an idea of what to do. We can find KB and BC. We can use base times height divided by 2. So for BC, we'll look at FE since they're equal. So FE will be the square root of 32 since it's the side length of this square. Now for KB, it's the same as JB because this is equilateral. And that's obviously going to be the square root of 18. It's the side length of that square. So now to find the area, do square root of 18 times the square root of 32 divided by 2. And the number inside is going to be 64 times 9. I'll rewrite that. So we can just rearrange within the square roots, right? We get 3 times 8 over 2. And that's equal to 12. Cool. Any questions? All right, we'll move on. Here we go, last 4. On June 1st, a group of students is standing in rows with 15 in each row. Underline that. On June 2nd, they're standing in one long row. On June 3rd, they're standing with just 1 student in each row. And then on June 4th, 6 students in each row. And this continues through June 12th, where there's a different number of students per row every day. Now on June 13th, they can't find a new way to do this. We want to know the smallest number of possible students in the group. So notice that the number of students in each row has to be a factor of the total number of students. So we're pretty much just looking for a number that has 12 factors. But we also know a couple of the factors. We're given 15 is a factor, 6 is a factor. We obviously know 1 is a factor, but that doesn't give us that much information. So 6 is a factor. That tells us that 2 and 3 are factors. And if 15 is a factor, that tells us 3 and 5 are factors. So putting these together, we know that 2, 3, and 5 are factors. Now we need to find a number with 12 factors that has these 3 numbers already as factors. So now we need to know, how do we find the number of factors in a number? Well, if we write out its prime factorization, in this case it's probably going to be 2 to the first power times 3 to the first, 5 to the first, times something else, but we'll just look at this number for now. How would we find the number of factors? Well, the prime, the number of factors of 2 would either have to be 0 or 1. So it'd be 2 to the 0 or 2 to the first. And then it would be the same for 3 and 5, where we have 2 choices for every factor. And that would give us a total of 8 factors. So basically what we notice is that finding the number of factors is just multiplying the exponents plus 1, because we have 1 factor, but that gave us 2 choices. So to get 12 factors, we would basically need a 3, a 2, and a 2 instead of a 2, 2, 2. So to keep the smallest number of students, we'll obviously want to change this 2, because that would minimize the impact. So we'll change this to a 2, and then we will change, here we'll add 2 squared, and we also have 3. Now we have 3 choices for the factor of 2. And that would give us a new total of 12 factors. So now all we have to do is just evaluate this. 2 squared times 3 times 5. We get 60. Any questions for that? Alright, cool. Let's move on. Problem 23. Tom has 12 slips of paper, which he puts in 5 cups. He wants the sum of the slips in each cup to be an integer, and he wants them to be consecutive and increasing. Numbers are given, and we also know a slip with 2 goes into E, and a slip with 3 goes into B. We want to know where the slip with 3.5 has to go. So we'll draw the 5 cups. Alright, so first we'll find the average of the cups. The numbers here add up to 35, so the average is 7. And since the average is 7, the middle cup will be 7, and everything else will follow from there. We're told that the numbers have to be consecutive and increasing. So these are the totals for each cup from A through E. So we're told that a slip with 2 goes into E and a slip with 3 goes into B. So if the slip with 3.5 goes into A, then there needs to be another 1.5. There's no slip that has 1.5, so A is definitely wrong. How about B? Well, if 3.5 goes into B, then what would we need? We would need a 2.5, right? Okay, so that could work. Now let's look at C. If a 3.5 goes into C, then we would need another 3.5, or 2 slips that add up to 3.5. Well, neither of those are possible, so C is definitely wrong. And since E has to have a 2, the rest of cup E adds up to 7, which is the same as cup C. So that also doesn't work. So now we're just left with B or D. Well, B actually doesn't work if we remember that a 3 goes into cup B. If we have a 3 and a 3.5, that's already too much. So the only choice left is D, and this looks fine. We have 3.5 with a 4.5, then we should be good. Any questions about that? All right. On problem 24. So a baseball league contains 2 4-team divisions, and each team plays every other team in its division n times, and every team in the other division m times. Given n is greater than 2 times m is greater than 4, and every team plays 76 games. So I want to know how many games a team plays within its own division. So we'll start by considering how many times a team would play within its own division. So we have 4 teams in division. Well, any one team would play 3 games at a time within their division. Like if they play 5 games, every other team in their division 5 times, that would be 15 games, right? So that's basically 3 times n. And 4 other teams, play them all once, 4 times for every game. So that would be 4m by the same logic. And this has to add up to 76. So we'll start by just testing with m at 5, since it has to be greater than 4. So with m at 5, 4 times 5 is 20. Got 20. So 3 times n would have to be 56. That's not possible because 56 is not a multiple of 3. So we'll try m equals 6, which would be 24 games here. And now we would be looking at 52 is 3 times n. That still does not work. So we'll go on to the next possibility, which is m equals 7. And that would be 28 games here. And that would mean 48 games for 3 times n. This works, and n would be 16. We can check that 16 is greater than 2 times 7, which is 14, so it satisfies all the conditions. So our answer is 48. Notice that even though n itself is 16, so let's place every other team in the division 16 times, that's a total of 48 because there are 3 other teams. Okay. Final problem. Here we go. We have 1-inch squares that are cut out from the corners of a 5-inch square. We want to find the area of the largest square that can be put in the remaining space. So if we do some experimenting, we might first try to go for like a diagonal sort of square. Pretty bad square. But this actually isn't the biggest that we can get. We can actually do better by like barely touching the sides or the corner of the cut. Like this. You can probably already tell that that's going to be bigger than just putting one square at the midpoints. So to find the area of this square, it's pretty ugly. There's no obvious way to find the side length to square it, but we can draw something like this. Break up this square into more friendly parts. So we know that total is 5. We also know this is 1, this is 1. So this remaining part is probably 3, right? So the side length of this big square in the middle is therefore 9. Now to find the area of these other triangles, we can use base times height. Base would be 3, and the height is going to be the same as the side length of the 1-inch squares, so 1. So 3 times 1 divided by 2 is base times height divided by 2. That's 1.5. So we have 9 plus 4 times 1.5. 1.5 for each of the 4 triangles. So this is 9 plus 6, which is 15. So if we look at the answer choices, 15, there's our answer. That's a pretty cool way to do this problem. We don't have to try to find the side length of the square. This is obviously a bit easier, right? Okay, that's every problem from the 2015 AMC 8. And if you are feeling generous, or if you found this helpful, please consider donating to my GoFundMe, which is to help local hospitals with COVID-19. All right. Thank you everyone for coming.